All right, folks, it's Bass Action, back in action here. In this video, we're going to look at the last two tools or skills that you can use when trying to simplify an identity. The first one that we're going to look at is division. Now, this is very similar to what we did on the top in the previous video, actually, when we were just writing things in terms of sine and cosine. But sometimes when there are multiple terms going on here, it makes it a little bit more complicated for students. So I'm going to show you a little trick that you can do on that. As always, we want to look at the angles and make sure that they match. We can notice right away on this one that they do not, but they are complementary. So we can use our complementary cofunctions. Now I'm going to use the complementary cofunction, and then I'm also going to do the first step in this little trick, so to speak, strategy for rewriting to kind of all in one. This numerator, I'm going to rewrite the numerator in terms of 54 degrees, since that's the odd one out. So this 36 is going to become a 54, and then the cotangent will become its cofunction or tangent. So cotangent 36 becomes tangent 54. Then I'm going to go ahead and I'm going to put that over 1. The next thing I'm going to do is I'm going to essentially pull apart this expression into 3 separate little fractions. So the secant 54 that's in the denominator, I'm going to keep it in the denominator, but I'm going to write it as its own little fraction. Then the sine 54 in the denominator, I'm going to pull that one apart too. So when you look at this, if you multiplied this straight across and multiplied this straight across, you would get right back to the original. This is often easier for students to visualize what's happening when they go to rewrite this in terms of sine and cosine. So tangent 54 in terms of sine and cosine is going to be sine over cosine. So sine 54 over cosine 54. Again, don't forget to write the angle measure. 1 over secant is actually cosine. So this is now going to become a cosine 54. And even though it's over 1, I'm still going to write it as an over 1. I don't want to just write the cosine 54. Putting it over 1 is going to help me better align numerators and denominators. Then I still have my 1 over sine 54. Oops, 54 there. And then I can see what's going to cancel. So sine 54, cosine 54, cosine 54. This whole thing simplifies to a nice 1. Let's do one more like that. The next one we're going to look at, the thing that's going to pop out to us, is that we have this negative angle here. So we remember that sine is an odd function. And if it's an odd function, sine of negative theta is the same as a negative sine of theta. So I can flip the angle to a positive and move the negative to the outside. Now I can rewrite this as all the separate little pieces. So a sine theta over 1, and then a 1 over a tangent theta times a 1 over a secant theta. Now I can start rewriting in terms of sine and cosine. Oh, lost my negative there. Then I'm going to have, so I'll have my negative sine theta over 1. 1 over tangent, that's my second term. 1 over tangent is cotangent, and cotangent is cosine over sine. Cosine theta over sine theta. Then 1 over secant is the same as cosine. So that's going to become a cosine theta over 1. So now I can see the sines are going to cancel, but I still have the negative, and I still have the cosine and the sine, or the cosine and the cosine. So this is going to simplify to a negative cosine squared theta. Remember, the squared goes between the cosine and the theta. Now in the next part, what we're going to do is we're going to look at how do we get from 2 separate terms into a single expression, because we can't do either of these processes until we have one single expression. So in our first problem here on this right-hand side, what's going to jump out is we have this tangent of negative theta. Tangent is negative, so I'm going to change the angle, or tangent is odd, so a tangent of a negative theta is the same as negative tangent theta. So instead of a negative angle, I'm going to pop the negative to the front, but then instead of writing it down here, I'm going to change this plus to a minus. So kind of, it's almost like writing the negative in front of the fraction. Now, what I want to do is I want to get a single expression. So I'm going to put the first tangent over 1. I'm going to multiply top and bottom by tangent theta. So now I can multiply straight across. My numerator is going to become tangent squared theta minus secant squared theta. And that's all going to be over tangent theta, that new denominator that I just got. Now, in one of the earlier videos, we looked at our Pythagorean identities. So tangent squared theta minus secant squared theta should jump out as a Pythagorean identity, and you should be able to recognize that that can be simplified to a negative 1. So I'll have a negative 1 over a tangent theta. And since we don't typically leave things in a fraction format, we can rewrite this as a negative cotangent theta. All right, let's look at another one. Again, two separate terms, nothing squared, nothing, we've got things added and subtracted, but nothing squared, no obvious Pythagorean identity I can do. So I need to get this as a single expression. So I'm going to put this over 1, multiply top and bottom by cosine theta. Now my numerator will become 1 minus cosine squared theta all over a cosine theta, and that numerator should jump out to you as a Pythagorean identity. The numerator is going to become a sine squared theta all over a cosine theta then. And then we don't really want to leave things as a fraction, so we're going to do a unique skill on this one. We're going to take that sine squared and we're going to rewrite it as a sine theta and a sine theta over cosine theta. What that's going to let me do is to kind of pull apart and group the sine over the cosine will then become a tangent theta, and then I'll still have one more sine theta there, and that will be my final answer. Got one more I want to look at here, and what's going to jump out to me is that my angles are different. I have two trig functions written in terms of 25 degrees and 2 written in terms of 65 degrees. So I do need to get all of those to match. What's going to jump out is that they are different but complementary. I am going to choose to keep the 25 degrees and I'm going to get rid of the 65. So my first one is going to stay sine 25, and then the denominator will become, the 65 will become 25, the sine will become cosine. On the next one, the sine 65, just like we just saw, will become cosine 25, and this is over a sine 25. Now, what I need to do here is I need to get some common denominators. So the first one, since my denominator is different on both of these, my first term is going to be multiplied by this denominator. The second term will be multiplied by this denominator. So I'm going to multiply this by a sine 25 over a sine 25, and then the second one's going to get multiplied by a cosine 25 over a cosine 25. So now the numerator is going to become sine squared 25 plus cosine squared 25 all over sine 25 times cosine 25. And again, we've got one more Pythagorean identity, that numerator sine squared plus cosine squared. This whole numerator simplifies to a nice 1. So I have 1 over sine 25 times cosine 25. 1 over sine 25 is a secant, or a cosecant 25, I meant to say there, cosecant 25. And 1 over cosine 25 is a secant 25. So that is our final answer there. So it really pulled together a lot of the skills that we've done in the previous video. So if I mentioned some skills that you weren't completely sure about, you can just go back and re-watch one of the other videos.